All right, you guys, in this section, we're going to talk about one-to-one functions as well as inverse functions. Okay. All right, so before we can begin to talk about one-to-one, you guys have to remember what a function is. Okay, so our formal definition for a function said, let x and y be two non-empty sets. A function from x into y is a relation that associates with each element of x exactly one element of y. Okay, so remember, another way to put that was every x has its own y. Okay, so we talked about functions before. So in this illustration, you can see that in this first set, which we're calling the domain or your input values or our x values, each x only maps to one y value. Okay, each one of these. Okay, so in each y value, this set that contains all of them, remember that's called your range. Okay, all right. So before, when we looked at functions, I would give you guys pictures to see if you guys could tell what I had given you. So if you're looking at this first picture here, okay, is it a function? Yes or no? It is. Yes, it is a function, okay? And it's a function because every x value only goes to one y value, okay? So it is a function. All right, what about this second picture? Is this a function? Yes, it is as well. Okay, it is also a function because each x value, each input, which happens to be animals, only goes to one y value. Okay, so both of these are functions. The difference is that this first picture, okay, this is a one-to-one function. Okay, and the difference is not only does every x have its own y, every y value, or in this case, population value, only maps back to one state value. Okay, so there's a one-to-one correspondence. So if you guys remember the example I gave you guys in class, if you're thinking about a function, okay, remember for a function, x cannot cheat, if you guys remember that. So if you're looking at your x values, every x better be matched up with one y value, okay? So it cannot cheat. For a one-to-one function, you can think about it as relationship goals. So a one-to-one function, okay, is hashtag relationship goals, which means that no one's cheating, okay? Which means that my x values only go to one y value and all of my y values only go to one x value. So you should only see straight lines straight across, okay? There should be no overlapping, no double dipping, okay? So no one cheats. So our formal definition of a one-to-one function says, a function is one-to-one if any two different inputs in the domain correspond to two different outputs in the range. That is, if x1 and x2 are two different inputs of a function f, then f is one-to-one if f of x1 does not equal f of x2, okay? So for a function, it just meant that every x, so for a function, okay, every x had its own y, okay? For a one-to-one function, every x has its own y, and every y has its own x. Okay, so for a one-to-one function, no one cheats. So if you guys want to think about these are like levels, okay? So you can't be one-to-one if you're not first a function. Okay, so if they ever ask you, is this one-to-one? Well, you have to check to see if it's a function first. So there's stages. You first have to be a function, and then you could be a one-to-one function. Okay, so if we're looking at these pictures here, okay, in this example, all right, so the picture in A, okay, this is a one-to-one function. Okay, so it first passes the criteria for being a function, which means every x has its own y, but it's also one-to-one because every y also has its own x. Okay, so this is one-to-one. The second example is a function, okay, because every x has its own y, but it's not one-to-one because every y doesn't have its own x. So if you look at this y1 here, y1 goes back to x1 and x2. So it fails the conditions for being one-to-one, but it's still a function, okay? And then c is not a function at all because it fails the conditions of being a function, because the criteria is that every x has to have its own y, but x1 goes to two different y values, so it fails, okay? So first you have to ask yourself, is the problem I've been given, is it a function? That's step one. And then you have to see, okay, is it one-to-one? Okay, cool. So those are the steps you're going to walk yourself through. So let's look at some examples. Okay, so in this example, they want us to determine whether a function is one-to-one. Okay, so notice it says determine whether the following functions are one-to-one. They've already told us that what they're giving us are functions. If they hadn't, we would need to prove that they were functions first before we prove if they're one-to-one functions, okay? Because remember, there's levels, okay? So we already know that they're functions, so we're good. So let's look at A. A says for the following function, the domain represents the ages of 5 males and the range represents their HDL, good cholesterol scores, okay? So it's a function because every x has its own y, but is it one-to-one? No, it isn't, okay? It fails the criteria for being one-to-one because of 38. 38 cheats, if you want to think about it. 38 maps back to 55, and it maps back to 61. So it fails because this one y value has two x values that it goes back to. So no, it's not one-to-one. Okay. All right, if we look at B, okay, we already know that it's a function. Every x has its own y. Now we have to see if every y has its own x. Okay, so we can go down the line. So 6, this y value is paired with -2. We need to see if we see 6 in any of the rest of our y coordinates. We don't, so this one's okay. Now we need to look at 3. We don't see 3 repeating in the y position. We look at 2. We don't see 2 repeating in the y position. We don't see 5 repeating in the y position. And we don't see 8 repeating in the y position. So this is a one-to-one function. Yes. This is one-to-one. Okay, so that's kind of how you have to walk yourself through that criteria. Okay, now sometimes they will give you a set like we just did, or a set of ordered pairs, and ask you whether or not the function that they've given you is one-to-one. Now sometimes they don't give you that. Sometimes they will give you a picture or graph and ask you whether or not that graph represents a one-to-one function. So if you guys remember back when we talked about functions, okay, before we got to one-to-one, we also had a graphical test. It was the vertical line test, okay? And the vertical line test told us if we drew vertical lines along our graph, and each graph only in each line, only intersect our graph in at most one place, then we had a function. So for example, if I had a parabola, okay, and I were to draw vertical lines on it, so something like this, each vertical line could only touch that graph in at most one place. If it did, the vertical line test told me whether or not I had a function, okay? Now we have something new called the horizontal line test, okay? The horizontal line test tells us if we have something that is a one-to-one function, okay? So its rules apply the same way as the vertical line test. It says for every horizontal line intersects the graph of a function f and at most one point, then f is one-to-one. So the same rules. So first, remember, anytime they ask you if your picture or your graph represents a one-to-one function, you would first, in your mind, need to determine whether or not you have a function to start with, because you can't be one-to-one if you're not first a function. So if we wanted to, we could do the vertical line test on this really quick. And if we drew vertical lines on this curve, we would see that each vertical line only passes through this curve in at most one place. So this curve passes, okay, the vertical line test, okay, which tells us that yes, it's a function. So before we even apply the horizontal line test, we would have to check that first. So after it's passed the vertical line test, then I could determine whether or not it's going to pass the horizontal line test. So I would draw horizontal lines, through my graph, okay? And we would see that this particular picture would fail. Each one of these horizontal lines that I'm drawing intersects this graph in more than one place, okay? So this fails the horizontal line test, which tells me that this function that's being represented here is not one-to-one. Okay, so those two tests go hand in hand. Vertical line test tells you if something is a function. Horizontal line test tells you if something is one-to-one. Okay, so let's look at some more examples. Okay, so remember, by our definition of one-to-one, one-to-one means that every x value corresponds to only one y value, and each y value corresponds to only one x value. Okay, so if we look at this first curve, this picture on the left, okay, if we wanted to know if this was a function, it would have to pass the vertical line test. So if I drew vertical lines on this graph, moving from left to right, we would see that it does pass. Okay, so it is a function. Okay, then I could see if it's one-to-one. I would draw horizontal lines across it. Okay, and each horizontal line only passes through it in one place. So it is also one-to-one. Okay. All right, if I look at this picture on the right, okay, this particular graph would pass the vertical line test. So if you draw vertical lines on this graph, okay, it would pass the vertical line test, which tells me that it's a function, okay? But it would fail the horizontal line test because as I'm drawing these lines across, for example, in this one place, I'm going to hit that graph in more than one place. So remember, if it fails anywhere, then it fails the entire thing. So this is not one-to-one. Okay, so just for future reference, any one-to-one function is a function. So you don't have to worry about that. But not all functions are one-to-one. Okay, so just be careful. All right, let's practice some more. Okay, so if we look at these pictures, okay, let's look at this one in the top left-hand corner. Okay, so this one is a function. Okay, it's a function because it passes the vertical line test. All right, so it passes, so it is a function. All right, it is also one-to-one because it passes the horizontal line test. Okay, so it's also one-to-one. All right, if we look at the picture on the top right-hand corner, okay, this is not a function, okay, because it fails the vertical line test, okay, so it's not a function. So because it's not a function, you don't have to check if it's one-to-one. It's not going to be one-to-one if it's already not a function and they haven't given us any domain restrictions. So you don't have to worry about it, okay? All right, this picture in the bottom left-hand corner, okay, once again, we've got a scenario that fails the vertical line test, okay? So it's not a function, so we don't even have to check if it's one-to-one. So we're good. All right, and the picture on the bottom right-hand corner, okay, this would pass the vertical line test, which tells us that it's a function, okay? And it would also pass the horizontal line test, which tells us that it's one-to-one, okay? So if they give you a picture or something like that, you can always walk yourself through the vertical and the horizontal line test and be careful of the information that each one of those tests can give you, okay? All right, now they could ask you to do something similar, okay, but they may not give you the picture. So they could give you a function that you can either type into your calculator or it may be a function that you're already familiar with. So it says for each function, use its graph to determine whether the function is one-to-one, okay? So this first function that they give us is f of x equals x squared. So notice they've already told us that we have a function. So we don't have to worry about figuring out if it is. We already know. So if you guys remember, let's make that a little straighter. All right, x squared is a quadratic function, okay? And the shape it makes is a parabola, so I'm just going to make a sketch. Okay, so they want to know, is this going to be 1-to-1? Well, in order for it to be 1-to-1, it would have to pass the horizontal line test. So let's see. Okay, so I've drawn horizontal lines through my graph, and each one of those lines is intersecting my picture in more than one place. So I would have to say no, this is not 1-to-1. Okay. All right, if we look at the second picture in B, we have f of x equals x cubed. So remember, that kind of looks like a snake is what I call it. Okay, let's see if it passes the horizontal line test. So if I draw horizontal lines across my graph, we're good. Each one of those horizontal lines only touches my graph in at most one place. So I could say yes, this is 1-to-1. Okay, so I hope by now you guys feel a little comfortable using the vertical and the horizontal line test. Okay, all right, let's look at this theorem. So this theorem says a function that is increasing on an interval I is a 1-to-1 function on I, and a function that is decreasing on an interval I is a 1-to-1 function on I. Okay, so this is really interesting. So it says if you have a function that is either increasing or decreasing on this particular interval you've been given, then it's going to be 1-to-1. So if you guys look at this picture, okay, this particular function is increasing on this interval that's been given. So as you can see, because it's increasing on this entire interval, it's going to pass the horizontal line test. Okay, same thing would happen if we had a function that was decreasing on the interval that they gave us. Okay, this is interesting because usually the only time a function will fail the horizontal line test is if the function bucks back. So what I mean by bucks back is something like a parabola, right? So a parabola looks like this, okay? And you can see that the parabola changes directions and it goes back up. So this parabola is decreasing and it hits its vertex and then it goes increasing. Because it changes directions, it automatically is going to fail the horizontal line test, which is why this theorem is so cool. So it says as long as you've got a function that's either increasing the whole way or decreasing, the function doesn't buck back and change directions, it's going to be 1-to-1. Okay, cool.